Do you want to learn how to create a level for a MetroidVania action, adventure, platform master game using free assets and Unity's tilemap features? Then keep watching. Welcome to MixtroidVania, a brand new Unity tutorial series where we create a 2D MetroidVania action, adventure, platform master game including building level environments with tilemaps, player input, movement and animations, different types of traps and enemies, combat, attacks, health and damage, collectibles, puzzles, loot and UI, as well as cameras, events, class inheritance, state machines, scriptable objects, and more. Hey there, I'm Ben, and welcome to GameDevMix, the channel about game ideas brought to life with Unity. In the last episode, we started to have a look at our game's visuals by adding multiple layers of background images and making sure that all of them are drawn in the correct order. We've also downloaded and imported the free level environment art assets that we are going to use in a number of episodes. So if you're new here, I'd recommend checking that one out first. Now in this video, we're moving on to our ground, walls and platforms. After all, that's where the action is going to happen. We'll work with the free assets we've imported in the previous episode and use Unity's tilemap features to create our game's very first level. When it comes to making games, a huge part is being able to make our own levels. In many 2D games, especially the old school classics, but even in much more modern indie masterpieces, levels are assembled piece by piece from individual building blocks called tiles, which are simply painted onto a grid. That grid, or more specifically, the one or more layers within it, is what's referred to as a tilemap. Tilemaps, therefore, are all about allowing us to create levels from individual tiles found on a tileset. And in the next sections of this video, we'll go over Unity's tilemap workflow step by step. With our background panels set up, it's time to move on to setting up our ground and our platforms. After all, that's where all the action is going to happen. To create our platforms, ground, walls, ceiling and so on, we'll be using Unity's tilemap feature. A tilemap simply is a grid that we can place individual tiles on to create our level. So in the project window, under Art, Environment, Foreground, select the Tileset asset at the top left. Then in the inspector, change the import settings as follows. Sprite mode, multiple. Pixels per unit, 16. Note that this value needs to match the dimensions of a single tile on our tileset. So if we were to use a different tileset, for example a tileset that's composed of tiles with a width and height of 32 pixels, then we would need to set the pixels per unit value to 32. However, in our case, our tiles are 16 by 16, so we need to set pixels per unit to 16. How small or large our tilemap actually appears on the screen, however, depends on this pixels per unit setting, as well as on the size of our camera and on the resolution of our game view, both of which we've set up earlier. Now under mesh type, I'm going to change it from tight to full rect. Generate physics shape, I'm again gonna uncheck for now because there will be a different way in which we create our actual colliders. Under filter mode, I'm again gonna select point no filter, and under compression, I'm again gonna select none since we are working with pixel art. I'm gonna click apply. And then I'm going to click the Sprite Editor button here to go to the Sprite Editor. Under Slice, for the type, I'm going to select Grid by Cell Size. And for the pixel size, I'm going to change it from 64 to 16 by 16. Pivot point I'm going to keep in the center. I'm going to click Slice. I always like to check that everything went as expected, and to do that I like to use this little black and white mode button up here at the top to help me see the individual tiles a little bit better, so you can switch between these different modes to just help you see the way in which these tiles were actually sliced. Finally, I'm going to click apply and I'm going to close this window. Now with our tiles sliced up correctly, the next thing is we are going to need to create an actual tile map. So in the hierarchy, we're going to right click and select 2D object tile map. This will create a new grid object with a tile map object underneath. The first thing I'm going to do is I'm going to take my grid object and rename it to Tilemaps, just to make it a little bit easier to remember what it's for. This grid object, now called Tilemaps, can hold multiple tilemaps. So if in future we add additional tilemaps, they will be placed under this one tilemap object as well. If we go to our scene view, then we notice that a literal grid of rows and columns has appeared on top of our scene in the scene view. So later on we're going to use this to help us paint in our level. Now still in the hierarchy here on the left, we're going to choose our tilemap object and we're going to rename it to platforms. Then in the inspector on the right, I'm going to check the static checkbox up here. And static simply means that we are not going to move this object, and as such it can be processed more efficiently for things such as physics, lighting, and so on. Under the tilemap renderer component, I'm going to change the sorting layer from default to platform. So we've just set that up a few minutes ago, so now we're going to use that. And yes, this basically just makes sure that our platforms get rendered in front of our background. Now, we don't have any platforms yet, so we can't see that. As previously with our background, I'm also going to adjust the tint color ever so slightly to give it a more personal look. And again, I encourage you to pick your own color or maybe keep the default. Now, of course, we don't have a tilemap yet, so we can't see it. So I'm just going to choose a very faint color here. And then if we want to, we can go back to this step later and change the tint color to make it more appropriate for the actual, once the actual tilemap is in. With our platforms tilemap created, I'm going to go to Window, 2D, and Tile Palette. This is the window we will use in a moment to draw our level using individual tiles. And basically, a tile palette simply is a place that holds a number of tiles and allows us to select those tiles and use them to paint in our level. I recommend docking the tile palette window to the right next to the inspector, so that it basically creates a new tab. Now in the tile palette window, we first need to create a new tile palette for our tiles to live on. So I'm going to click Create New Palette here, and then for the name, I'm going to name it Platforms, and I'm going to click Create. When prompted for a location to save the new tile palette to, navigate to the root, so to the Assets folder, and then I'm going to create a new folder called Tilemaps. I'm going to click Create, and under that I'm going to click and create another new folder called Palettes. I'm then going to select that palette folder and click Choose to save our new tile palette to that folder. That's our tile palette created. However, we notice that it's still empty. So the next step is to actually add our tiles to our tile palette so that we have something to paint with. This is similar to a normal paint palette in real life, where we first need to add some paint to it that we can use. In this case, our tiles act as that paint. So in the project window under Art, Environment, Foreground, I'm going to select this one individual tile set at the very top left. I'm going to drag that onto my palette. Now I just want to make sure these are the tiles that have been sliced. So I don't want to select these or like individual ones or all of them. That's not what I want to do. I want to take the tile set itself and I want to take it and drag it onto our tile palette. And what this does, selecting this single asset, is it ensures that the arrangement of the tiles on the tile palette will match the arrangement of the tiles on the tile set. Once Unity has finished processing, you'll notice that our tile palette now contains all of the tiles from our tile set. With our tilemap and tile palette set up, the next step is to actually build our level by selecting our tiles on our tile palette and then painting them onto our tilemap. Now before we get started, a little word of warning. When painting tiles onto our tilemap, we need to make extra sure that we have selected the correct so-called active tilemap. Here at the top of the tile palette window, in this case platforms, as well as the correct tile palette here on the top left. Since we only have one tile map and one tile palette right now, this won't be a problem just yet, but it is good to keep it in mind for future reference. When it comes to painting tiles onto our tile map, we have a number of tools at our disposal. The brush tool is used to paint single tiles. The rectangle or filled box tool is used to paint multiple tiles. The bucket or flood fill tool is used to fill in a whole area of tiles. And the eraser tool is used to undo any mistakes we might make. The process is simple. We select a tile on our tile palette, then paint that tile onto the tile map. So we've got our active tile map platforms, we've got our tile selected, and then what we can do is, if we choose the correct tool, the brush tool, then we can start painting. We can select different tiles and paint those tiles, and step by step we can basically create our level. So here's what I want you to do. Build your level by selecting tiles from the tile palette, then painting them onto the tile map until you're happy with the result. Now, one thing to take into consideration is that our player character will be about one tile wide, so that's this wide, and just a little under 2 tiles tall. Our player will have about these dimensions. So you might want to take those reference values into consideration when it comes to heights and distances, thinking about whether or not the player character will actually be able to make it up onto a platform height-wise or across to another platform lengthwise. However, keep in mind, this isn't rocket science, and you don't need to be super accurate right now. Chances are you're going to change the layout of your level many times. You're going to iterate on it and adapt it to your changing needs as you progress in the development of your game. Later on, we'll also look at a different way of painting tiles called rule tiles, which makes it significantly easier and much faster to draw tiles onto a tile map. So for now, simply draw something to get you started. And remember, if you mess up or if you want to change something, you can always just use the eraser tool. If you aren't sure how big your level is, it's useful to zoom out, and if you have a look at that slightly thicker, slightly brighter white line here, that's your camera view. So at least for now, I would recommend to make the level just a little bit bigger than what fits into the camera viewport. Right, so I went ahead and created my own version. Here's what it looks like. Let's have a look in the game view. So I've just kept it really, really simple, just giving the player something to large surface here to walk on, something to fall down onto, and something to jump up. And what I've also done is I've added walls here to the sides of my level just to make sure that the player doesn't fall off the edges of the platform. I've decided to keep it really, really simple, at least for now. Now that we have built our level, there's only one more thing left to do in this episode. One of the most important parts of any MetroidVania action-adventure platformer style game is the ability for a player to stand on platforms, get blocked by walls, and so on. Without that ability, our player character would fall through the ground, fly through walls, and who knows what else. So what we need to do is add the ability for our platform tiles to work with collisions. Later on, this will ensure that our player character, our enemies, NPCs, and so on, are able to get blocked by our platform tiles rather than fall straight through them. Now, one solution might be to manually place colliders on top of our current level. For example, a number of box colliders for the various platforms, for the walls, and so on. We could do that for each individual tile, or perhaps a little more efficiently for rectangular groups of tiles. So it would be a little something like this. And what I could do now is I've got a collider for here, and then I could take that collider, I could duplicate it, and I could move it around. This isn't very convenient, and in practice, levels are often iterated upon. So we often create a level, test it, then add a bit more, change some, and so on. So it's very rare that a level is drawn just once and is perfect right away. So with that in mind, adding a bunch of box colliders on top of our level really isn't a great idea, because every time we change our level, we would need to move and resize our various box colliders. So I'm going to get rid of those here. Fortunately for us, there's a better way. And that better way is called a Tilemap collider. A Tilemap collider is a special type of collider that was specifically made for Unity's Tilemap system and automatically updates as we paint our tiles onto our tilemap. So it takes care of tile-related collisions for us. In the hierarchy, select our platforms object. Then in the inspector, add a new component and look for Tilemap Collider 2D. This is a collider around every single tile on our tile map, represented by a little green box. So if we have a look here at our grid, we can see all these little green boxes have appeared. And so there's a green box around every single tile. And the cool thing about this is if we now go back to our tile palette and we add more tiles to our level, so we paint additional tiles, then these tiles as well automatically get assigned that collider, that little green border around them. So it's very, very convenient. So with this, it's easy for us to iterate on our level as many times as we like without having to worry about setting up colliders. This is pretty great. However, we can do even better. Because of our current approach, the problem is that every single one of the tiles on our tile map now has an individual collider. But tile-based games often have tile maps with hundreds or even thousands of tiles. So using an individual collider for each individual tile isn't very performant. And there's another problem with using individual colliders. It likely won't function correctly. Our player character is likely to get stuck just walking across the ground as they hit the corners of our individual tile colliders. So the corners between these colliders. There often is problems where the player character gets stuck and just doesn't behave in the way that we would expect them to behave. Fortunately for us, Unity has yet another component which can take these individual colliders, these individual boxes, and combine them wherever possible, solving both of the problems we've just discussed. And to enable this, we first need to again select our platforms tile map, and then in the inspector, under the Tilemap Collider 2D component, we need to check this box here called Used by Composite. Now for this to work, we need to add another component to our platform's tilemap called a Composite Collider 2D. So we're going to click Add and search for Composite Collider 2D. And you may notice right away that now, instead of having individual colliders around each individual tile, our colliders wrap around the boundaries of our level's various groups. So all of this here, all of our ground and our walls is considered one large group, and then we've got this platform object here in the center, and that's considered another group. So we've got one big collider wrapping around our ground and our walls, and another big collider wrapping around our so-called platform. And just like before, if we go back to our tile palette here, these colliders get updated. So if we add another platform, then that gets a collider as well. And even if we were to like move stuff around here, if we were to remove a little bit, make a little bit of a pit here, then again, that gets updated. Our composite collider updates right away. So that's just extremely convenient. There's one more thing we need to do in relation to our colliders. Because when we added a composite collider to our platform's tile map, Unity automatically added a rigid body 2D component as well, because composite collider just happens to require a rigid body 2D component. So the problem with this is this. If we press play, what's going to happen is our level is going to fall. Under our rigid body 2D component, we need to change the body type from dynamic to static. So if we now click play, then our tile map stays in place and everything is great and nothing falls. Perfect. Now there's one more thing I want to do, and that's I want to talk about physics layers. Now physics layers provide an easy way for us to control what collides with what. So if we go to layers at the top and select edit layers, then under text and layers, this time we're going to select layers, not sorting layers. And now we're going to select an empty layer here, for example, user layer 8, and we're going to give it a name. So I'm going to start with one that's called platforms. Then I'm going to have a next one, another one called player, and then another one called enemies. Now you might be wondering, wait a second, haven't we already set up these sorting layers earlier? Yes, we have, but there's a difference. Sorting layers are for the visual appearance of a game object, so it decides what gets drawn on top of what, and these layers here, or as I like to call them physics layers, basically decide what collides with what. So there's a difference between the visuals and the actual physics or collision behavior. Back in the hierarchy here on the left, we're going to select our platforms object, and then in the inspector, we're going to change the layer at the top from default to our new platforms layer. We're going to use this in one of our future episodes to detect collisions between the player and our platforms, between the enemy and our platforms, with the help of Unity's layer collision matrix. But more of that later on. And that's it for this episode of our MixtroidVania tutorial series. Now, I am curious. Do you think there are any other important considerations when it comes to this topic? Anything I forgot? Perhaps something you would do differently? Let me know in the comments below and let's learn from each other. With our platform's tilemap now set up, it's time to flesh out our level and make it more visually appealing. After all, our current level just isn't up to snuff yet. So tune in next time, where we'll start off with the basic, bland and, if we're honest, slightly boring looking level we've created in this episode and turn it into this much more visually appealing masterpiece. We'll create more tile palettes and tile maps to add backdrop caves, bridges, trees and foreground decorations and really level up our level. So if you want to keep following along, make sure to tune in next time. But for now, thank you very much for watching this episode. I hope you received value from it. And if you did, I would really appreciate it if you could click the like button below the video to let the YouTube algorithm know to show the video to a broader audience. And if you want to see more videos like this one, including the next episode, don't hesitate to click the subscribe button and hit the bell icon to be notified when new videos are released.